Linear inequalities. Inequalities. These are special equations where the equal sign is replaced by inequality signs, that is, greater than, less or equal to, greater or equal to. For example, x plus 3 is equal to 0 is an equation. X plus 3 is greater or equal to 0 is an inequality. The statement x is less than 2 means all numbers less than 2. Such information can be represented on a number line as shown below. Note that the arrow indicates that the values are endless. When greater or equal to and less or equal to are used, the starting points are shaded, meaning they are part of the solution. The greater than and less than have no shaded parts, meaning the starting points are not part of the solution. We can also combine inequalities. For example, x is less or equal to 3 and x is greater than minus 2 can be combined to be 3 is greater or equal to x, which is greater than negative 2. This is represented on a number line as shown below. This is the range of values that satisfy the inequality 3 is greater or equal to x, which is greater than negative 2, meaning x lies between minus 2 and 3, but minus 2 excluded. X is less than 5 and x is greater than 0 becomes 0 is less than x, which is less than 5, or 5 is greater than x, which is greater than 0, meaning x lies between 0 and 5, but 0 and 5 excluded. Solutions of linear inequalities. The inequalities are solved in just as if the sign was an equal one. However, if we multiply or divide both sides of an inequality by a negative number, the sign reverses. For example, minus 3x is less than 21. Dividing both sides by minus 3 reverses the sign and we have x is greater than negative 7. 2. A third y is greater or equal to 4. If we multiply both sides by minus 3, we end up with y is less or equal to 12. Examples: solve the following and represent the answer on a number line. A. 4 plus 2x is greater or equal to 5. B. 3 minus 2x is less than 5. C. A third minus 2/3 x is less or equal to a third x minus 2 over 3. In the solution, 4 plus 2x is greater or equal to 5, x is greater or equal to 4.5 and is represented as shown. B. 3 minus 2x is less than 5, x is greater than 1. Note the change or the reversing of the sign, and it's represented as follows. Also note that the initial point is not shaded. 1 over 5 minus 2 over 3x is less or equal to 1 over 3x minus 2 over 3. If we rearrange, we have minus x is less or equal to minus 1, and x is greater or equal to 1, and is represented as shown with the original point shaded, meaning it is part of the solution. Solving simultaneous inequalities. These are inequalities that must be satisfied at the same time. We solve each separately and then combine the results. For example, solve the following. A. 3x plus 2 is greater or equal to 7, and 2x is less than minus 3x minus 15. B. X is less or equal to 5x minus 9, and 2x is greater or equal to 4 minus x. In our solution, A, 3x plus 2 is greater or equal to 7. 3x is greater than 9 and x is greater than 3. 2x is less than minus 3x plus 15.
5x is less than minus 15 and x is less than minus 3.
Combining the two, we have 3 is less or equal to x, which is less or equal to minus 3. B. X is less or equal to 5x minus 9, and x is greater or equal to 4 over 9. 2x is greater or equal to 4 minus x. 3x is greater or equal to 4, and x is greater or equal to 4 over 3. Combining, we have 9 over 4 is less or equal to x, which is greater or equal to 4 over 3. Graphical representation of linear inequalities. Inequalities can be represented on a Cartesian plane. For example, x is less or equal to 5. This can be represented as shown below. The shaded region is the unwanted region, and shaded region represents the region that satisfies the inequality. A continuous line indicates the boundary is also part of the solution. Dotted or broken line indicate the boundary is not part of the solution. Graphical solutions of simultaneous linear inequalities. Linear inequalities in two unknown are solved to find a range of values of the two unknowns which make the inequality true at the same time. The solution is represented graphically by a region. Represent graphically the region satisfying the following inequalities. X is greater than 1, y is less or equal to x minus 2, and x plus 2y is less or equal to 6. In the solution, assume the inequality signs to be equal signs, but remember the type of line, whether broken or continuous. Line x is equal to 1 is direct. Line y is equal to x minus 2, we form a table of values and get only 2 points. When x is 2, y is 0. When x is 3, y is 1. Therefore, we plot those points and join to form a straight line. X plus 2y is equal to 6. 2y is equal to 6 minus x. We take two values and substitute. When x is 0, we have y is 3, and when x is 2, y is also 2. Plot the points 0, 3 and 2, 2 join to form a straight line. To get the required region, take any point on any side of the line. Substitute the coordinates into the inequality and see if it satisfies the inequality. If not, that point is on the unwanted side of that line. For example, taking line y is equal to x minus 2. Let's take a point 5, 2. Substitute in y is less or equal to x minus 2. That is 5 is less or equal to 2 minus 2. This is not true, and hence the point 5, 2 is on the unwanted side. Shade that side of the line. Repeat the same for other two lines. The region marked R satisfies the inequalities listed above.